Hi everyone, you are welcome to my channel, educative channel on the Guru Brainstorm. First and foremost, my name is George Solomon Mukan, aka the Guru Master. As a teacher and a lecturer that has been in this field for several years, I've been privileged to come across several students that often complain about further maths. In fact, whenever you tell them or you mention further maths, it becomes boring to them. Reasons: further maths is difficult to understand. Two, the teacher presenting the further maths is not good enough to break it step by step. Three, studying further maths on their own is difficult for them to understand. But today, I want to assure you that all those challenging problems associated to further maths has come and it will go. The only thing you need to do is to follow me step by step as we progress and advance in this video. And at the end of the day, don't forget to share and subscribe this video. And as well, do not forget to click the notification button. The reason is subsequent videos will always be updated to you so as to follow up throughout my channel. Now today I want us to look at further mathematics. Further mathematics, the topic is laws of indices. Objectives: by the end of the lesson, students should be able to 1. Differentiate between index and indices. 2. State the laws of indices. 3. Solve at least one example with respect to each laws of indices. Presentation. From the objective, the first objective says differentiate between index and indices. Indices means powers. The plural form of index is indices. Index is also referred to as exponent or power. The following are the laws and facts about indices. We have generally 7 laws of indices, but in some textbooks you see 3, you see 4, you see 3, you see 4, and so on and so forth. But today I'm going to give you the 7 laws of indices with several examples with respect to each law. The first law is known as addition law. That is a to the power of x times a to the power of y is equals to a to the power of x plus y. For example, 1. When you have 3 to the power of 4 times 3 to the power of 2. Remember the law says a to the power of x times a to the power of y. A here means 3. And then x, which is the power of a, the first term, is 4. And then y, which is the power of the next term, is 2. Now, having known this, you can proceed by saying 3, which is corresponding to this a, to the power of x, which is what? 4. Plus y, which is 2. So when you do your mathematics, you have 3 to the power of 4 plus 2 is 6. That is all. Now, the next example is, for example, when the bases are different, like this. 4 to the power of 2 times 2 to the power of 3. You multiply the two bases together because the bases are different by saying 4 times 2 bracket close to the power of x plus y. Our x here is 2 and y is 3. That is, we have 2 plus 3, which gives us 4 times 2 is 8. 2 plus 3 is what? 6. So these are the two conditions. Either the bases are the same or the bases are different. Then you follow this example. Now, the second law is this. It is 2 plus 3 is 5 rather. So we have 8 to the power of 5. Now the second law is called subtraction law. Subtraction law. That is, when you have a to the power of x divided by a to the power of y. Since the bases are the same, we have a to the power of x minus y, and that is why it's called subtraction law. For example, 1. When you have 4 to the power of 2 divided by 4 to the power of 1. You have, since the bases are the same, you have 4 to the power of x, which is 2, minus power of y, which is 1. So you have 4 to the power of 2 minus 1 is what? 1 or 4. It's the same thing. But in a situation whereby the bases are different, assuming you have this question like this, 4 to the power of 3 divided by 2 to the power of, let's say, 2. The two bases are different. So what you do is, you apply this division principle by saying 4 divided by 2 to the power of x, which is what? 3, minus y, which is 2. So you have 4 divided by 2 is what? 2. 3 minus 2 is what? 1 or 2. 2 raised power 1 is as well 2. Now that is the second law of indices. Now let's consider the third law of indices. The third law of indices is also called multiplication law. Multiplication law. That is when you have bracket open, a to the power of x bracket close to the power of y. Then you have a to the power of x, the powers multiply themselves. So a to the power of x times y. And that is why it's called multiplication law. For example, when you have 1, when you have 3 to the power of 2, bracket close to the power of 3, you have 3 to the power of, this 3 is equivalent to a. X is now 2 times, y is what? 3. So you have 3 to the power of 2 times 3 is what? 6. That is multiplication law. So the fourth law is written as a raised power 0 equals to 1. In most textbooks, they will say 8 to the power of 0 is 1. But the question is, how comes about 0 and how comes about 1? Here is the solution. Now, we derive this applying the second law of indices, which is subtraction law. Now, when you apply that, you have a raised power x divided by a raised power x. We're applying the principle of second law there. So since the bases are the same, you pick one base, which is a to the power of x. You can see that the powers are the same. The difference between this is that in second law of indices, the powers are not the same. But in some cases, it might be the same. So you have x minus x, which is x minus x is what? 0. So you have a raised power 0 equals to 1. And that's how we got this fourth law of indices. Now, remember that either whole number or fraction raised to the power, that either whole number or fraction raised to the power of 0 is equal to 1. For example, when you have 3 to the power of 0 is 1, or when you have half to the power of 0 is equals to 1. That's all about the fourth law of indices. Now let's consider the fifth law of indices. Remember, I told you that we have 7 laws of indices, and I'm going to give you the 7 laws with examples with respect to each. Now the fifth law of indices is also written as a raised power minus x equals to 1 over a raised power x. I know some persons will begin to ask, how comes about a raised power minus x? We also apply the second law of indices, known as subtraction law, to obtain this. Now let's try it. We have a raised power 0 divided by a raised power x. We have a raised power, the bases are the same. The powers, we have 0 and x, so we have 0 minus x equals to 0 minus x is what? Is minus x. That is, we have a to the power of minus x. So it's written as a to the power of minus x, which gives you 1 over a raised power x. So that is how we got this. For example, let's consider at least one example with respect to this. For example, when you have 6 to the power of minus 3, Now here a is equals to 6 and x is equals to what? 3. So applying this law of indices here, we have 1 over 6 to the power of 3, which is corresponding to this. 1 over a, which is 6 to the power of x, which is what? 3. So simplifying further, we have 1 over 6 to the power of 3 means 6 multiplying itself 3 times. So we have 6 times 6 times 6. So we have 6 times 6 is what? 36. So I have 36 times 6. Let's work it out. 6 times 6 is 36. You write down 6, carry 3. Now 6 times 3 is 18. 18 plus 3 is 21. That is we have 216. So that means finally we have 6 raised to the power minus 3 can be written as 1 over 6 to the power of 3, which is equals to 1 over 6 times 6 times 6, which is equals to 1 over 216. So this is with respect to 5th law of indices. Now let's consider the 6th law of indices. The 6th law of indices can be written as continuation. The 6th law of indices says 8 to the power minus x equals to 1 over 8 to the power of x. So we start continue from there. So if we have 1 over 8 to the power of x, it can be written as x root of a. X root of a. And that is the 6th law. For example, when you have 1 over a raised to power, or maybe you have a raised to power 1 over 2, it can be written as square root of a. When you have a to the power of 1 over 3, it's written as cube root of a. When you have a to the power of 1 over 4, is written as 4th root of a. Now let's try to solve one example and see. Now assuming you have 8 to the power of 1 over 3, that means cube root of 8, and it's written as cube root of 8. Now cube root of 8 here can be determined by determining all the factors of 8 and then selecting one of the factors that when it multiplies itself 3 times it gives you 8. And what are the factors of 8? We have 1, we have 2, we have 4, and 8 itself. Looking at the factor, you agree with me that 2 is the best factor. Now let's confirm. 2 to the power of 3 means 2 times 2 is what? 4. Times 2 is what? 8. That means 2 is the cube root of 8. So that means cube root of 8 is equals to 2. Assuming you have 9 to the power of 1 over 2, it means square root of 9. And it's written as this 9. This sign means square root, so you don't need to write 2 here again. Now what is that factor? Out of those possible factors of 9, which of those factors, best factors that can multiply itself twice to give you 9? I think you agree with me that it's 3. Let's confirm. 3 times 3 is what? 9. So that means square root of 9 is what? 3. So that's all about 6th law of indices. Now let's consider the 7th law of indices. Let's consider the 7th law of indices. 7th law of indices, which is the last law, can be written as a to the power of x over y. Now I want us to look at this very properly. I want to split it and see if we can simplify it to a simpler form that we can understand. Now looking at this, it can be written as a to the power of 1 over y times x. I believe you agree with me that 1 times x is x over y, which is still referring to this. And you agree with me that this is 6th law of indices. That is y root of a, which is written as y root of a. That means this is 6th law. Now multiply with the power of x. Now this x is a power. So that means in conclusion, we can say that the 7th law is a to the power of x over y equals to a to the power of 1 over y times x. This term is the 6th law, which is written as y root of a. You have this to the power of x. So whatever you have as y root of a, you square it with this power x, which could be 0, 1, 2, 3 until you get to heaven. Now, for example, for us to understand this law very well, let's consider two examples. For example, let's consider example 1. Assuming you have a to the power of 2 over 3. This is 7th law of indices. I want you to understand that a is equivalent to 8, and then this x is written as 2, and then y can be written as 3. If that is understood, then we can proceed by saying that a to the power of 2 over 3 can be written as a to the power of 1 over 3 times 2. You agree with me that a to the power of 1 over 3 is the 6th law of indices, which can be written as cube root of 8. Cube root of 8. This 2 is this power x, which I told you that whatever you have, you square it with the power which is x. It could be 0, 1, but the power of x here is 2. So you enclose everything in a bracket and write your 2 here. Now all you need to do is, what is the cube root of 8? Looking at the possible factors of 8, which is 2, 4, and 8, the best number that can multiply itself 3 times to give 8 is 2. That means cube root of 8 is what? 2 to the power of 2. So you have 2 to the power of 2 does not mean 2 plus 2, but 2 times 2. 2 times 2, which gives you 4. So in a nutshell, a to the power of 2 over 3 gives you 4. Now let's consider example 2. Example 2. Assuming you have 9 to the power of 3. 9 to the power of minus 3 over 2. Assuming you have this. This question has to do with 6th law and 7th law of indices. But first and foremost, before you apply the 7th law, you will first of all apply the 6th law to simplify it further and bring it to 7th law. Now the question is, what is the 7th law? I mean 6th law. 6th law is written as a to the power of minus x, which is equals to 1 over a to the power of x. Whether whole or fraction is the same thing. So if it is true, then it means that we can transform this as 1 over 9 to the power of 3 over 2. If it is true, then we can go further by simplifying that is the same thing as 1 over 9 to the power of 1 over 2 times 3. This denominator, 9 to the power of 1 over 2, is the 6th law of indices, which is telling you that is square root of 9 you are looking for. Now it is written as this. Now remember this one, 1 over square root of 9 to the power of 3, which is equivalent to x. Now 1 over square root of 9 is what? 3. Because 3 times 3 gives you 9. Don't forget this power. To the power of 4, you just write 3 here. So you have 1 over 3 to the power of 3 means 3 multiplies itself 3 times. So you have 3 times 3 times 3. That gives you 1 over 3 times 3 is what? 9. 9 times 3 is what? 27. So the answer now is 1 over